Bien, pues muy buenos días, tengan todas y todos ustedes. En nombre del Instituto Mexicano de Tecnología del Agua, les damos la más cordial bienvenida al inicio de este Coloquio Internacional, Soluciones basadas en la naturaleza para la gestión hídrica. Muchísimas gracias por acompañarnos, tanto en la plataforma Zoom como a través de redes sociales del Instituto Mexicano de Tecnología del Agua, totalmente en vivo. Les invitamos a que nos acompañen en la sesión de hoy, que está de lo más interesante. Tendremos la sesión inaugural y la conferencia de apertura, y que nos acompañen también, por supuesto, a lo largo de todo el mes de junio, prácticamente martes y jueves, a que lo tengan muy presente en su agenda, porque tendremos de verdad un gran programa de conferencias, de mesas redondas de discusión, un espacio sin duda importante si estás interesado en conocer soluciones basadas en la naturaleza vinculadas con el tema del agua. Yo quisiera, sin más preámbulo, comentar que en este acto inaugural estará presidido por el subsecretario de Ordenamiento Territorial y Agrario, el arquitecto David Ricardo Cervantes Peredo, y también estará presidida por el director general del Instituto Mexicano de Tecnología del Agua, el doctor Adrián Pedrozo Acuña. El subsecretario David Ricardo Cervantes Peredo, en el marco de su labor con organizaciones no gubernamentales, estuvo al frente de Casa y Ciudad AC y del Instituto de Vivienda de la Asamblea de Barrios AC. Fue integrante de la primera Asamblea Legislativa del Distrito Federal, diputado federal de la 62ª legislatura por el Distrito 30 de Tlalpan, diputado local para el Distrito 40 en la Asamblea Legislativa durante la 7ª legislatura. Formó parte del equipo de gobierno del Distrito Federal en la Dirección General del Instituto de Vivienda en la Administración de 2000 a 2005. Entre sus principales funciones está la de ser responsable del Programa Nacional de Reconstrucción. Yo quiero en este momento darle la más cordial bienvenida al subsecretario, desearle muy buenos días y lo escuchamos con muchísima atención. Subsecretario, muy buenos días. ¿Cómo se encuentra?
¿Qué tal? Buenos días a todas y todos. Agradecemos, por supuesto, la invitación para participar en el coloquio. Nos parece muy importante la realización de estos eventos y quisiéramos, pues, compartir con ustedes cómo desde esta Secretaría y el ramo del gobierno federal vemos la problemática con respecto a la garantía del derecho humano al agua, cómo lo venimos aplicando. Y bueno, nuestro punto de partida es el asumirlo como responsabilidad de Estado, como lo señala la Constitución, en cuanto a que estamos obligados, ¿verdad? Y además por convicción, porque ese es uno de los principios de este proyecto de la 4T, a reconocer, proteger, garantizar todos los derechos humanos. Y es así el caso del derecho humano al agua. Hemos venido trabajando desde el ramo con una visión transversal de los derechos humanos y lo hemos venido tratando de aplicarlo así desde pues, las atribuciones que nos corresponden, es decir, asumiendo la responsabilidad específica. Y así podríamos destacar que en materia de ordenamiento territorial hemos modificado la concepción del ordenamiento del territorio para ver el territorio integralmente, no con esa, pues pensamos, división artificial entre lo que es el asentamiento humano y lo que es la naturaleza, sino que tiene que verse integralmente los asentamientos humanos, el medio ambiente, las cuestiones de patrimonio cultural, el riesgo, en fin, y que esto nos da una perspectiva distinta para el ordenamiento del territorio, y esta perspectiva la hemos incorporado ya en los lineamientos para la elaboración de los programas de ordenamiento territorial, y esto incluye específicamente, para hablar del derecho humano al agua, que el ordenamiento del territorio debe de considerar el enfoque de cuenca y la gestión integral del agua. Eso ya quedó establecido en los lineamientos para todos los programas, ya sean regionales, estatales, municipales, comunitarios, del ordenamiento del territorio. Y algo que también nos parece muy importante es que todo esto lo venimos haciendo de manera coordinada con la Semarnat, de manera que ambas secretarías y ambos ramos, que son como la parte del gobierno que tiene mayor responsabilidad en el ordenamiento del territorio, trabajemos conjuntamente con esta nueva visión integral del territorio. En materia del mejoramiento urbano, pues ya también se han incorporado como componente fundamental de las acciones del mejoramiento urbano, que tienen como propósito mejorar las condiciones del hábitat en las colonias de más alta marginación, las acciones de introducción de redes de agua y de drenaje para cumplir con el garantizar el acceso. Ahora, como no solo se requiere o no es suficiente contar con la infraestructura, en esto venimos trabajando también con la Conagua para garantizar el suministro, ¿verdad? Porque pues de nada serviría tener tubos si no hay el líquido. Entonces, pues esto también ya viene siendo un componente de las acciones de mejoramiento y que tienen también pues, la orientación de contribuir a garantizar el derecho humano al agua y además hacerlo de una manera adecuada. Y así, en materia de vivienda, el que también se reconozca el derecho humano a la vivienda implica considerar sus 7 componentes y uno de ellos es el garantizar el acceso a los servicios básicos. Ahora, todas las acciones, todos los apoyos del ramo para vivienda, además de estar orientados a los sectores de más bajos ingresos, también consideran que debe en todos los casos cumplirse con este componente. No podemos apoyar la construcción de una vivienda y que al final sí tenga su adecuación cultural, sí corresponda a las necesidades de la familia, pero que al final pues no tenga acceso a los servicios. Entonces, esto también forma parte importante de las acciones que está llevando a cabo el ramo. En materia agraria pareciera que no tiene mucha relación, pero nosotros decimos que sí, al aplicar esta visión de manera transversal, todas las acciones que llevamos a cabo en materia agraria, que tienen la finalidad de pues contribuir al ordenamiento interno de los ejidos y comunidades, a la emisión de documentos para garantizar certeza jurídica de manera colectiva o individual, a llevar a cabo también la solución de conflictos respecto a tierra y territorio, en fin. Todo esto al final nosotros lo hacemos con el propósito de contribuir a que los ejidos y comunidades ejerzan plenamente su derecho al territorio, y esto incluye la posibilidad de participar en el manejo de los recursos hídricos que existen en su territorio, es decir, con base en lo que señala nuestra Constitución, por un lado, respecto a la potestad del Estado y la responsabilidad del Estado para el manejo del agua, también corresponde reconocer los derechos de ejidos y comunidades, y sobre todo cuando se trata de comunidades indígenas, al goce de su territorio. Entonces, también desde las acciones agrarias está contemplado el cómo se contribuye a garantizar este derecho. Y finalmente, en materia de gestión de riesgos, hemos incorporado ya en todas nuestras acciones la visión o el enfoque de la gestión integral de riesgos, y eso nos ha llevado a que en los procesos de reconstrucción, sobre todo cuando son procesos en los que ha habido un desastre provocado por inundaciones, ya sea por desbordamiento de ríos, de grandes avenidas de agua, por lluvias torrenciales, por daños a la infraestructura en el manejo del agua, en fin, se lleven a cabo acciones también integrales que no solo restablezcan las condiciones adecuadas para el manejo del agua, sino también medidas de mitigación y prevención para que al final de cuentas el agua no se convierta en una amenaza para la población, sino que sea un elemento que siempre podamos manejarlo para satisfacer el uso de ese recurso natural para los asentamientos humanos. En fin, esta es una forma en la que hemos intentado cumplir con esa obligación desde nuestro ámbito específico y en particular para reconocer, proteger y garantizar el derecho humano al agua y por supuesto, pues esto que hemos venido haciendo está sujeto a evaluación por el propio presidente, por la ciudadanía, y es muy importante, pues para la acción de gobierno, saber si lo estamos haciendo bien o hay que hacer correcciones. Y por último, creo que es importante, y así lo hemos visto desde acá, desde el ramo, que para lograr que como gobierno federal alcancemos a cumplir adecuadamente con esta obligación de conocer, proteger, garantizar los derechos humanos, es indispensable la acción coordinada del gobierno. Sin ello, vemos muy difícil, dado que cada vez más se requiere de la interacción no solo del gobierno federal, sino también de los 3 niveles de gobierno y sobre todo de la participación de la comunidad, pues sería sin ello muy difícil conseguir estos objetivos. Entonces, para ello nos parece que pues resulta muy importante la realización de eventos como este y esperamos, por tanto, pues mucho éxito en su desarrollo y agradecemos nuevamente la invitación a participar. Muchas gracias.
Muchísimas gracias, arquitecto David Ricardo Cervantes Peredo, subsecretario de Ordenamiento Territorial y Agrario de la Secretaría de Desarrollo Agrario, Territorial y Urbano de México, la SEDATU. Muchísimas gracias por su mensaje, muchísimas gracias por formar parte de este evento y por supuesto que los trabajos que se generen y que se compartan y todas las discusiones pues estarán a disposición de todos los programas y toda la visión que tiene el gobierno para poder garantizar pues un ordenamiento territorial y los derechos humanos en nuestro país al agua, al saneamiento y, en fin, a todo lo que tiene que ver con una vivienda y con el uso adecuado del espacio. Muchísimas gracias, subsecretario. Que tenga muy buen día. Y es momento de escuchar ahora el mensaje y también la declaratoria formal de inauguración de este coloquio internacional Soluciones basadas en la naturaleza para la gestión hídrica a cargo de el doctor Adrián Pedrozo Acuña, director general del Instituto Mexicano de Tecnología del Agua. Doctor Pedrozo, muy buenos días, lo saludamos con muchísimo gusto, lo escuchamos con mucha atención.
Muy buenos días, estimado Marco. Quiero aprovechar esta oportunidad, desde luego, para saludar a nuestro querido subsecretario David Cervantes de la Secretaría de Desarrollo Urbano y Territorial del Gobierno de México. Pues decirles a todos, darles la bienvenida a todos a este seminario, segundo coloquio internacional de infraestructura verde, que desde el sector ambiental estamos impulsando, en particular desde el Instituto Mexicano de Tecnología del Agua. Me parece que lo que hoy estamos viendo, esta sinergia, agradecemos desde luego también al secretario Román Meyer por dar el tiempo de los funcionarios de esta importante secretaría para compartir y conocer lo que desde el ámbito, digamos, más científico, académico, relacionado al conocimiento del agua, se está proponiendo. Yo quisiera aprovechar mi reflexión y esta bienvenida para compartirles justamente que desde el sector ambiental estamos impulsando una nueva visión para el manejo del agua. Es evidente, en todo el territorio lo vemos, que la manera en la que se han tomado decisiones relativas a este elemento fundamental para la vida no ha sido la correcta. El gran número de conflictos que hay en el país, y no nada más en nuestro país, sino en África, en Asia, en Latinoamérica, en Estados Unidos, en Canadá, respecto al acceso a agua segura, nos indica que el paradigma justamente de gestión integral de recursos hídricos, que considera solamente una visión tecnológica, ingenieril para las decisiones del agua, no es suficiente. Desde luego es muy importante contar con una visión técnica y contar con una visión, un lente de cuenca de la conectividad hidrológica y de los flujos al interior de un territorio, pero también es importante considerar las dimensiones relativas a la equidad y la justicia. Vemos, y desde en la historia de México, vemos en la Revolución Mexicana, en el estado de Morelos en particular, con el movimiento del Ejército Libertador del Sur, vemos una clara preocupación por la tierra con el movimiento del Ejército Zapatista. Pero no nada más era la tierra, era también el agua, eran los montes. Y esto necesariamente nos obliga a nosotros como especialistas en temas hídricos a tratar de generar la reconexión que existe y que vemos entre agua y territorio. ¿Cómo vamos a hacer esto? Pues nosotros creemos en el IMTA a través de 3 principios axiológicos que son el uso de la ética en nuestro quehacer, desde luego, actuar de manera ética siempre poniendo el conocimiento científico más adelantado que hay en el mundo a disposición de todas las autoridades del Gobierno de México, no solamente del sector ambiental, y además actuar con transparencia. Creemos que el dotar de información relativa a los flujos, a la cantidad de agua, a la cantidad de agua que hay en los acuíferos, a la lluvia, a toda la sociedad, nos permitirá generar un ecosistema de acuerdos a partir de la misma información base. Así entonces, pues este coloquio se presenta justamente como un esfuerzo que intenta renovar la ingeniería del agua en este país. Y renovar la ingeniería del agua en este país significa trascender justamente las soluciones de gran escala, las soluciones de las grandes plantas de tratamiento, de las grandes presas, por soluciones locales de pequeña escala que nos permitan atender problemas, por ejemplo, como el de la contaminación difusa en ciudades. Necesitamos entonces conectar el conocimiento científico del agua con las decisiones del sector ambiental, con las decisiones de la Secretaría de Desarrollo Urbano, con las decisiones de energía, porque el agua, como ustedes saben, el agua es el elemento de la vida y el agua está en todas partes. Creemos que la capacidad del IMTA, entonces, que evidentemente se sustenta en la generación de conocimiento científico y tecnológico, y por la naturaleza de este quehacer académico, pues la generación de conocimiento es necesariamente una labor colectiva. Y es una labor colectiva no nada más a escala nacional, sino a escala global. Y por eso hoy estamos muy contentos de contar y de abrir este coloquio con un especialista connotado de Francia, Jean-Luc Bertrand Kasseski, quien hoy nos hablará justamente del diseño de soluciones basadas en la naturaleza. Necesitamos entonces, de la mano del esfuerzo global y de la mano de los especialistas locales, generar una nueva ingeniería del agua, una ingeniería del agua que permita hacer de este elemento el elemento clave para el desarrollo y la generación de bienestar de este país. Muchas gracias y les deseo a todos felices reflexiones y un gran aprendizaje en este coloquio que durará todo el mes de junio. Muy buenos días.
Muy buenos días, muchas gracias, doctor Adrián Pedrozo Acuña, director general del IMTA, por este mensaje y formalmente pues es la declaratoria inaugural de este coloquio internacional, Soluciones basadas en la naturaleza para la gestión hídrica. Y pues sin más preámbulo, les invitamos entonces a permanecer para dar paso a la sesión técnica de esta primera jornada del coloquio, que tendrá pues su desarrollo a lo largo de todo el mes conforme al programa que con mucho detalle, con mucho cuidado, Laurent Corti, el coordinador general de este evento, y todo el equipo han coordinado, han organizado para que tengamos toda la mejor experiencia de conocimiento y de análisis, sobre todo de, como comentaba el doctor Adrián Pedrozo, de construcción colectiva del conocimiento. Yo quiero muy rápidamente darles algunos mensajes técnicos para que aprovechemos de la mejor manera esta experiencia que tendremos en el coloquio. Estamos paralelamente en diferentes plataformas por el momento. Estamos en Zoom. Otro grupo estamos también conectados a través de redes sociales, en Facebook Live y también en Twitter de la Cátedra UNESCO IMTA, el agua en la sociedad del conocimiento. Las sesiones están siendo grabadas de manera íntegra, de forma que si alguien está interesado en revisar el contenido de una presentación, de una conferencia, pues la vamos a tener disponible en YouTube, en Canal IMTA y también en redes sociales quedará disponible para todas y para todos los interesados. O si alguien no tuvo oportunidad de presenciarlo en vivo, se pierde alguna sesión, pues tenga la seguridad de que va a encontrar en esta plataforma, en el canal IMTA de YouTube, pues encontrará también estos seminarios de manera completa junto con un gran acervo de otras temáticas vinculadas con el conocimiento del agua. Entonces, estamos grabando estos seminarios y como ustedes notaron, quienes se encuentran en la plataforma Zoom, todos los micrófonos de momento se encuentran bloqueados y así van a permanecer a lo largo de la sesión. Sin embargo, muy importante la interacción con todas y con todos ustedes, y esta será a través del chat. Por escrito estaremos al pendiente de recibir sus preguntas, sus comentarios a lo largo de la sesión, desde que inicie, de hecho, la presentación de nuestro conferencista de esta mañana. Estaremos recibiendo sus comentarios, sus preguntas y al final de la presentación, el moderador de la sesión, el doctor Laurent Corti, dará paso a sus comentarios y a sus intervenciones. Y de la misma forma, en redes sociales estaremos muy al pendiente de que planteen ahí también sus preguntas y sus comentarios. Tenemos en Zoom la plataforma también de traducción simultánea. Es sencillo, en la plataforma tienes en el menú inferior un icono con un planeta y dice ahí interpretación. Entonces tú seleccionas simplemente el idioma en el que quieres escuchar la conferencia y la charla y así estaremos conectados a lo largo de toda esta sesión. Yo quiero entonces en este momento ya dar paso a que tengamos pues esta conferencia inaugural que estará a cargo del doctor Jean-Luc Bertrand Krajewski del Instituto Nacional de Ciencias Aplicadas de Lyon, Francia. Y para presentarle y para moderar esta sesión, yo tengo el gusto de saludar esta mañana al doctor Laurent Corti, coordinador de hidráulica del Instituto Mexicano de Tecnología del Agua y también coordinador general de este Coloquio Internacional Soluciones basadas en la naturaleza para la gestión hídrica. Doctor Laurent Corti, ¿cómo estás? Muy buenos días, te saludo con mucho gusto y escuchamos con muchísima atención tu conducción de la conferencia inaugural de este coloquio. Muy buenos días, Laurent.
Hola Marco, muy buenos días y muy buenos días al subsecretario, el arquitecto David Cervantes y también a Adrián Pedrozo, el director del IMTA. Me da mucho gusto que estén aquí y muy buenos días a todos los invitados y asistentes. Soy Laurent Corti y voy a ser el moderador de esta sesión. Que va a presentar el doctor Jean-Luc Bertrand Krajewski, que es profesor en el Departamento de Ingeniería Civil y Planificación Urbana en el Instituto Nacional de Ciencias Aplicadas de Lyon, en Francia, desde el 1997. Es director del laboratorio DEEP, que es el Laboratoire Déchets, Eau, Environnement, Pollution, que es el Laboratorio de Desechos Sólidos, Agua, Ambiente y Contaminaciones, desde 2014. Sus principales temas de investigación son la hidrología urbana y los sistemas urbanos de agua, especialmente el modelado de transporte hidráulico y de contaminantes en sistemas de alcantarillado, monitoreo de campo y metrología, manejando aguas pluviales, sistemas urbanos de drenaje sostenibles y un enfoque integrado para sistemas de agua urbana, con numerosas colaboraciones nacionales e internacionales. El profesor Jean-Luc Bertrand Krajewski fue presidente del grupo de especialistas en drenaje urbano de la International Water Association del 2005 al 2008 y miembro del Consejo Estratégico de la E.U.A del 2010 al 2018. También fue presidente de la ONG francesa GRE, el Grupo para Investigación, Coordinación Técnica e Información del Agua del 2011 al 2017. El GRE es el organizador de las conferencias internacionales de Novatec sobre gestión del agua urbana. El profesor ha escrito más de 220 artículos a la par en revistas y conferencias. Más información y publicación están disponibles en su sitio web, que es jlbkpro.free.fr. Doctor Jean-Luc Bertrand-Krajewski, es un placer, un verdadero placer y honor tenerle hoy para esta ponencia. Y le voy a dar la palabra ahora al profesor Jean-Luc Bertrand-Krajewski. Adelante, profesor.
Okay, good morning to everybody. First of all, I would thank a lot Laurent Courty and IMTA for their invitation to participate in this colloquium. It's a really great privilege to talk to all of you today. And I also want to thank them also for the adverse conditions they had to organize this event. With the pandemic, which forced them to postpone and modify the event. Thanks a lot also for your very detailed and kind introduction. I will share with you today some ideas and thoughts about urban stormwater management. And I will adopt a multidisciplinary and integrated approach with a few historical background, because I like to present our field and discipline always with having some roots in the past to know where we come from and how we can evolve in the future. I like this picture. It was made in the second half of the 19th century in the city of Hamburg in Germany. Maybe you know, maybe you don't know, but in 1842, there was a big fire in this city which destroyed something like 1/3 of the city. And they decided to rebuild the city entirely with new concepts. And they invited British engineer, William Lindley, to make the master plan of the city. And he created this system, which was the first full-size application of the emerging hygienist concept in his time. And you can see on this graph, you have buildings. They need drinking water with sufficient pressure to fight against any future fire, because it was a big disaster for this city. But you can also see that you have water supply at different levels in the houses. You collect wastewater, and the wastewater is discharged into a combined sewer system, where the stormwater from the paved roads is also collected. So this graph was among the first ones, not really the very first one, but among the first ones to make a map, a scheme of how to manage both waste and stormwater in cities in a modern sewer system. And this modern sewer system was then spread everywhere in the world, especially by means of engineers, European engineers who traveled everywhere across Europe first, but also in Asia, in Africa, in Australia, and they disseminated this approach to solve the wastewater problems and to manage stormwater in cities. And the key concept was based on 3 ideas. Connect. So the idea is to connect as much as possible all the buildings, all the impervious surfaces to this collecting system, to evacuate, the second point, the stormwater, as fast as possible, jointly with the wastewater in case of a combined system, or separately to the nearest available surface water course, for example, if you have a separate system. And in that time also, there was no reason to treat. The main objective was evacuate to avoid disease, which were attributed to the miasma. They were working with this miasma theory, considering that people were sick because of small living particles in the air, in the atmosphere. And so the idea was to evacuate the water as fast as possible. So connect, evacuate, don't treat. Very quickly, two concepts emerged. The separate system, where you have two separate collecting systems, one for stormwater with direct discharge into the rivers or lakes or ponds or in the sea if you are on the shore, and another collecting system for wastewater. In the early beginnings, for the first, let's say, 50, 60 years, there was no treatment. So the wastewater was discharged directly into the rivers. And after some decades, when they observed that rivers were more and more seriously polluted, they decided to introduce wastewater treatment plants. But it was not like that in the early beginnings. On the other side, you have the combined system, where you have a unique pipe collecting both waste and stormwater. And once they introduced wastewater treatment plants, as they had a limited capacity, they created these overflow structures to discharge the excess of water beyond the maximum treatment capacity of the treatment plant directly into the rivers. And it was assumed that this water was contaminated by the wastewater, but that the overflow occurred only during high flows when the wastewater was sufficiently diluted to have no or very limited impact on the rivers. Both hypotheses were wrong. The first one is that stormwater was not polluted, so it didn't require treatment. And the second one, that assuming that everything was sufficiently diluted to be negligible, was also wrong. But they started like that with this stormwater management. And it was the case for decades and decades. And if you look at my city of Lyon in France, this is the area of the city in 1950. And the orange part is the urbanized area. So this is the total territory of what is nowadays Greater Lyon. And you can observe over the decades the increase of the urbanization. And it has more or less tripled in 60 years. And if you have in mind that in the historical part here in the city center, they have built, like in many other European cities, they have built a combined sewer system. And progressively, with the extension of urbanization, with the urban sprawl, they have connected more and more water to the system. And something which was sufficiently designed at the beginning became too small. So they needed to increase the system. Maybe you are familiar with this graph, so we will not enter into details again, but we left from a natural catchment where half of the water is evapotranspirated and transferred as surface runoff, and the other half as shallow and deep infiltration. And as you increase your urbanization, you reduce evapotranspiration drastically, you increase more drastically runoff, creating a lot of problems, transporting pollutants, creating floods and inundations, and you decrease also significantly infiltration and the refill of the aquifers. So this trend was combined with the extension of urbanization. So it's not simply that you urbanize more and more on the same area, but also that the area you urbanize is growing. And what is the consequence is always larger and larger and larger pipes. Because one of the traditional engineering approach is, if I can say it like that, if you don't solve the problem with a big pipe, you will solve it with a larger pipe. So the trend was just increasing the size of the pipes. So I like this drawing, but it's not only a drawing, no. You have this type of big pipe in the US, but in other cities worldwide. So you build larger and larger and gigantic infrastructures to evacuate stormwater. So it's no longer a proper solution. because the gigantic infrastructures has also a gigantic cost and drawbacks at the end. The other aspect is it's not only a question of water, it's also a question of pollutant loads. And historically, in the 60s, 70s of the 20th century, people started to monitor, I would say, the traditional pollutants like BOD, COD, total suspended solids, nitrogen, phosphorus, just to compare with wastewater. But progressively, they realized that, okay, it's not only these pollutants which are transported in stormwater, but also heavy metals, hydrocarbons, and more and more during the last 20 years, a big focus is given on micropollutants or emerging pollutants. Okay, the pollutants usually are not emerging, it's our interest in them, which is emerging. So we have to deal also with pollutant loads, which have been neglected for decades, which forces us to revisit our approach. And these sources of pollutants are numerous in cities. First, some of the pollutants may arrive directly with the raindrops themselves. They transport some dissolved and very fine particles named aerosols, which are the support of several pollutants. You have the dry atmospheric deposition, which occur between storm events during the dry periods, coming from all the local and sometimes very distant emissions of particles, aerosols, by industry, by houses, by traffics. You have the erosion of the soil in the cities, on the streets. You have the erosion of the cars, of the particles they transport, they emit. You have erosion of the road surfaces. You have the roof material, which is eroded and also transports some pollutants. You have some organic matter coming from leaves, from animal feces, from different types of waste that inhabitants are leaving, abandoning on urban surfaces. Even if they are not systematically directly connected to the sewer system, you have also some parks, gardens, natural soils, which may contribute to the flux of water and pollutant loads during very significant storm events. And all these pollutants are transferred through the street inlets to the pipe systems, which are either separate or combined sewer systems. These two systems transfer in the last phase their pollutants to water bodies, rivers, lakes, and other recipients. In addition, we have also a lot of problems related to sediments, which have been relatively well documented in combined sewer systems, which are resuspended during storm events, and which makes difficult to close mass balances of pollutants when you try to make a mass balance at a catchment or a city scale. So this is what we know today and what we have to deal with. And I will give you a few examples based on the case of Lyon. So this is the map of France, Paris, maybe you know, and Lyon here. This is the second or third city of France. And this is the Lyon city center. We have two big rivers. So the Rhône River coming from the French Alps and the Saône River coming from the northeast plains of France. The confluence is in the city of Lyon, and then the water continues to flow into the Mediterranean Sea in the south. Like many typical cities, it's very, very developed and impervious in the city center. You can also observe that on this city, the east side on the left of the photo is rather flat, while the west side on the right side is more hilly and a little bit less urbanized. So it's a very contrasted city. And for historical reasons, all the city center is equipped with a combined sewer system and all the part in the west. And on the east side, there is more or less no surface water courses. So they could not evacuate the stormwater into a river because there is more or less no river. So in this extension of the city in the east part, they had to use stormwater infiltration since the 70s. So the city of Lyon had to face special context, and they had to manage the stormwater in two different ways, with combined systems in the west and with separate system in the east. Of course, they were like many other cities. So in Lyon too, they had big pipes, big tunnels, even the big ones you create or you build with tunnel boring machines. So the cost of such infrastructures is very expensive per kilometer. So they had to do that, like many other cities, and they pay a lot of investment to make this infrastructure. And the city center, this is near the main railway station. You can see that Lyon is not really famous for parks and gardens. It's you can see some trees and parks, but the amount, the fraction of the area of the city covered by this park is rather limited. So they have a very dense mineral city center, obviously with a reduced infiltration capacity. And over the last 20 years, the heat islands effect increased dramatically. And for example, 2 years ago in July, we reached more than 41 degrees in the city center. So you have the typical combination of urbanization, loss of infiltration, heat island effect, and all related problems that you have to deal with. But Lyon is not only like that, because as I said, on the east side, they had to manage the stormwater in a different way. At that time, it was not named nature-based solution, but the philosophy was a little bit similar. And in the French technical vocabulary, it was named alternative techniques, which means an alternative to pipe systems. So abandon the systematic collection and evacuation of stormwater, but try to intercept and infiltrate locally. And this is what they built in the 70s. So this is a typical facility from this time in the 70s. So it's the first part of a big tank. This part is the storage and settling tank. And after settling, the stormwater is discharged on the left into an infiltration tank. So the idea was to combine storage to intercept all the fine particles in the water, in the stormwater, to intercept by the same way the particles and the pollutants attached on these particles, and to infiltrate in the local aquifer the stormwater after settling. In the 70s, it became very popular. This facility, you can see on this figure, the bottom area is 1 hectare, so it's a quite large unit. But of course, it was, I would say, designed only by engineers. No? Straight lines, not very nice looking facility. And progressively, at the turn of the 80s, they created something more attractive. They replaced this type of bottom and with this quite horrible black plastic sheet of black plastics all around by something with grass, stones, and you can infiltrate the water there. They introduced, however, fences because it was considered as a closed space with no public access, and it was considered as a technical object for water specialists. But it was the first attempt to have something more nice looking and more integrated in the landscape. However, it was still designed mainly by engineers, not by landscapers. And over the last 50 years, they considered progressively that stormwater was no longer an urban nuisance, but became a valuable resource. I will explain later on why they were working in that direction. Initially, they started to deal only with quantity, so how to manage cubic meters per second and the volumes of cubic meters. And they introduced progressively water quality issues in their thinking, in their design, and in the management. And progressively also they moved from a pure hydrological and hydraulic approach to a multi-purpose approach, because any square meter in a dense city is quite expensive. So if you use it only for stormwater, it may be considered as a very expensive approach, and you lose your space, which is used only a couple of days per year during big events. And the most important aspect also was that they moved from a technical separate issue. Stormwater management was only in the hands of water specialists. And the water specialists were invited at the end of the urban projects of city planning. Okay, we have designed the city or the future part of the city, and please, can you come and make the stormwater management in this area? And they move from this, I would say, separate last moment approach to more fully integrated urban projects, when the stormwater specialists are involved since the early beginnings to contribute to the design, the concept to be applied in a given new urban area, or in an area where you retrofit the existing urbanization. One of the consequences was that stormwater professionals were acting, interacting, and collaborating more and more with other people, with their water colleagues first. Because when you refill, for example, the aquifer with infiltrated stormwater, you have some stakes to deal with about water resources, drinking water production. You have to manage in a coherent way your collecting systems and your wastewater treatment plants. So they had to discuss more with their water colleagues. They had also to discuss much more with landscapers, with gardeners, with architects, city planners, also with public transport and road specialists. If you have something like porous pavements and you make your road with this type of pavement, you have to interact with people in charge of roads and public transport. You also have to work with people in charge of solid waste. And I will comment later on about these issues. So it was a progressive, but really clear and significant transition. And to do that, you need motivated people, because you are doing something which is against the traditional silos of city management. It's never easy, and it's a long lasting process to embark everybody in a coordinated and integrated approach with engineers and technicians from different disciplines. And this is a famous project in Lyon, which is named Porte des Alpes. And you have here a more recent design. They made this project in the beginning of the 80s. So there is no more fence around. It's no longer a technical object closed for the public. On the contrary, it's open for the public. You have picnic areas. The shore of the lake, this is an artificial lake to manage stormwater with a permanent water level. The shore is has a very mild slope so that you cannot fall in the water to avoid accidents. You have picnic areas, you have ways and walkways all around, so people are invited to circulate, to visit the place. The unique forbidden activity is bathing. However, there are some photos where people are swimming in this pond. It's not recommended. And this facility was monitored, and they made an inventory each year to look at the fauna and flora. And they have discovered that it was many species came and developed and grow there, even some protected species like this type of salamander and this type of orchid. So they grow, they came there naturally and they grow. And this pond, which was initially an artificial stormwater pond, is becoming progressively a kind of lake with its own local biodiversity. And this is monitored over the years to observe how this stormwater pond is becoming progressively a very rich water ecosystem. But Porte des Alpes was an easy case because it was on the east side of the city when they decided to replace an agricultural area by an urbanized area. So you have lots of space and you have a free area to do what you want. This second example is near the city center, so very close to the railway station I mentioned briefly before. In this case, it's a retrofit, so you reorganize a very dense part of the city, and you have to deal with stormwater management in the historical part of the city. And this is much more challenging because here the square meter is much more expensive. You had to get some additional space, and you will see later on how they had an integrated approach to design this area. The idea is that you can also have different infrastructures, for example, like green roofs. So this is a metro station in Lausanne, in Switzerland, where they have developed a green roof and green wall with different vegetation species. So you can integrate your stormwater management system really into your infrastructures and into your architecture. This is the famous case, maybe you know it already, the Potsdamer Platz in Berlin, where you have this pond filled with local stormwater. And the stormwater, you have a complete scheme of reuse for irrigation of the green roof on the top of the buildings, to be used as a cistern for firefighting, and also to make some balance between the stormwater and the river water during the summertime. And you have also an area of this pond in this part, which contain also some algae and vegetation to do some nutrient uptake and extraction and some filtering effect. So this is quite a mineral environment with water, but however, it's another way to really integrate stormwater management with some natural aspects into a complete project. And you have this example in Japan, where they created this administrative building, and the challenge was, we need to create a building, but we don't want to lose any square meter of green space. So they had this very unusual shape for the building, but you can extrapolate the ideas to have a kind of urban farm. So I have no time today to discuss all these details, but there are quite interesting ideas to develop the cities of the future. And today, the paradigm has changed. So we abandon the systematic connection, evacuate and don't treat, by something which is disconnect maybe as much as you can. For example, in some parts of Lyon, it's now forbidden to connect your stormwater to any pipe. So the motto is disconnect your water, infiltrate as close as possible to the source where the rainwater is falling, and treat when and where it is necessary, depending on the pollutant loads you have on a specific area. And the other approaches are be sustainable, so save, use, reuse, recycle your stormwater, don't evacuate it very quickly to the nearest stream. Be resilient, adapt, modify, retrofit the existing city, and to do that in a more efficient way, you need to collaborate and integrate disciplines. A few other examples in the city of Lyon. Each opportunity to reduce imperviousness, to add some vegetation, to add possibilities for stormwater infiltration is used. So each square meter has its own value. So each possibility is used. So year after year, the change is minor, but if you have a very long-term strategy, it will really change your city after 30, 40, 50, 60 years. So if you want to manage your stormwater with this type of approach, you need also a long-term vision and to have to be consistent in your policy over decades and not changing every 5 or 6 years, because it's a long-lasting approach. But at the end, it pays. When I'm speaking about multidisciplinarity, I don't mention only technical aspects, because for decades or 1.5 century, the water was left in the hands of water specialists. So people were educated to think about water as a fluid, mean of transport. They were very good in hydrology, hydraulics, calculating flows, volumes, concentrations of pollutions. So something mainly based on physics and chemistry. But water incorporates many other values. Water as a meaning, water as some very strong link with culture, with history, geography, with symbolisms, with modes of life. So if we consider only water as a fluid which is transferred in the city, we lose a lot of its meanings, of its significance, and even the way we consider it is maybe not appropriate. And this is very well presented in this book, written by a Canadian philosopher, Jamie Linton. And his approach was this one, he suggested that many of our problems with water we have today is due to the fact that we consider it only as a physical and chemical compound. And he's proposing in his thesis presented in this book that we should reintroduce many other values of water to have a much more holistic approach of water. And if we introduce more things about culture, history, values, and symbolism in our approaches, it will really help to have a better urban water management. So you don't need to agree with the ultimate conclusions or even to the premises of his book, but it's a very nice invitation to think water with a different perspective. And if I come back to this example of Lyon, what they needed from a technical point was an infiltrating swale. So they needed to infiltrate stormwater. That was the idea. But beyond this technical aspect, this figure is taken from a document from Greater Lyon. So it's not an interpretation of what they did. It's really how they worked. So it's okay, we are in the city center. We don't have enough green spaces. So we need to use the opportunity of stormwater management to add a green area. Okay, it should be also good for the neighbors, for the citizens. So a fountain is good because it will give also a visibility to water, and with a very limited treatment, disinfection, cheap disinfection system, you can introduce your stormwater in a fountain. Historically, this was the limit of the city of Lyon in the Middle Age. So they adopted this design to remind the walls which were all around the city in this period. So you have some historical signs to remember and some explanation panels in the area to explain what it was. And so we have recreated this moat to remember this historical aspects of the city. You create also a new landscape, so you give more visibility to other parts of the city. You have a playground for kids. You have a cooler space because you have shadows, you have green areas, and it's also a friendly area where people are gathering, discussing. So you have the opportunity with one technical object to incorporate many diverse dimensions and having something which is much more integrated. Okay, it can be considered as nice ideas, and I have given examples from Lyon, but you have many similar examples in different countries in the world. So this is also nothing very exceptional by itself. This trend is observed in many countries in the world. But then we can think also to social aspects. Are nice green-blue environments for all? There is a risk of social segregation, which is usually in gentrification, linked to the new or retrofitted urban stormwater systems. When you create such an environment, it's more attractive, it's more nice looking, and it's more pleasant than the traditional completely asphalted or concrete surroundings in cities. So you have a higher price per square meter. And what are the social values, benefits, and quality for citizens? And recently, I read this paper. It was published in 2019, how to embed social inclusiveness and appropriateness in engineering assessment of green infrastructure to enhance urban resilience. And this paper explained that, and I agree with it, that when you make a project, there is a lot of technical and engineering criteria to design and to evaluate its performance. But we should also really include social aspects, how people will behave, how their well-being will be improved or not. And we should go beyond just nice intentions, or it will be better for the inhabitants. But the question is, how can we quantify that? Can we really include these aspects in the project and have some preliminary thinking about what we can expect and how people will benefit from this infrastructure? For example, this is the case of Confluence District in Lyon. It was historically, until 10, 20 years ago, a former industrial area, which was more or less abandoned. and it has been retrofitted. Now it's one of the most active districts in the city with water around. Just to give you an idea, it's the confluence between the Rhone and the Saône River. So it's nice looking. You have these buildings, you like it or not, but it's a playground for architects. But behind the buildings, you have green spaces, and on the front, you have this water. And it's an area which is very attractive, but also with among the most expensive prices for buildings in the city of Lyon. On the other side, you have this example I have visited in Montreal, in Canada. On the left, you have social houses, small ones with two levels, and all the small houses were around the parking lot. And the city of Montreal decided to change the stormwater management, to introduce infiltration, to reduce the parking lot, to introduce stormwater management, infiltration, a more green area. And they started to present the project to the inhabitants and asking them, okay, what do you think about the project? And initially, the inhabitants were not enthusiastic. And people say, okay, why? Oh, the project is nice, but if you do it there, the price of our houses or flats will increase. And with our low to medium salaries, we won't be able to stay there any longer. It will be something for richer people. And we will be forced to leave the place. And the municipality said, no. We promise, and they signed the contract, and it was proven that there is no change in their prices when you rent the flat. And then the people say, okay, if in that case, let's go. And they even contributed. They gave the inhabitants some kind of lectures and trainings about stormwater management, about gardening, about maintenance. And this is how it is developed now. And it's becoming also attractive. People have picnics, they have developed some gardens around. And so it's just one example to show how social aspects have and can be included in the project. Also, for a long time, we designed the cities more or less against nature. We wanted to domesticate nature and to make the city as we wanted by neglecting the natural environment and natural context. And among many other ones, Jan McHarg was among the pioneers to promote design with nature instead of against. And his book, published in '69, was one of the milestones in this field of how to account for nature, and not nature only as an ecosystem, but also with the social value and the asset value of nature. And we are in cities where nature is more and more asked by citizens. And how can we reintroduce and develop nature in cities? Of course, it's nature, when you discuss with people, it's not the wild nature. They are in cities and they like a kind of domesticated nature, but they want something more green in cities. And you have to deal with that by also including geography, history, landscape, some sociology, anthropology, and even philosophy in your approaches, to have something which is adapted locally to the culture, to the habits of the local inhabitants. And you can do some significant retrofit. Maybe you know also this example is the Cheonggyecheong River in Seoul, in South Korea. So it was like that in the middle of the 70s. I don't remember how many lanes for this highway. And, but now it has been retransformed into something more natural to some extent. And over 6-7 kilometers, the pre-existing river, which had been completely covered and hidden for decades, has been reopened and transformed. And from one point from upstream to downstream, you move from very natural to very mineral environments. And you have lot of symbols of the Korean culture and the relation between people and water in this area. This district is nowadays one of the most popular places in Seoul, Korea. More recently, a new consideration emerged. It was biodiversity. So the idea is to maintain and to obtain, if it's possible, a richness of species, of genetic diversity, of endemic species, and having also an ecosystem diversity. And how can we include this in the approaches we have when we design stormwater management in cities? One of the most typical approaches is this blue-green corridor vision. So when you create some spots, and not only spots, but also more important is corridors, where the different species can circulate, move to create and recreate very frequently the continuity of your ecosystem. And it's a very long-lasting task, of course, and ambition, because you need to reconnect and recreate some continuity which have been very frequently destroyed in the past in the cities. And the idea is to move from gray infrastructure, and typically pipes and sewage systems, to green infrastructure. And the last step, at the moment at least, is this blue-green infrastructures, where we interconnect networks of natural and semi-natural areas, combining both water bodies, green and open spaces, helping to promote and to restore biodiversity in urban environments. So I did this graph more than 10 years ago, and to try to summarize the evolution of stormwater management. And if you go from the 60s, 70s, it was mainly hydraulic control, how to manage stormwater only in terms of discharges and volumes. And progressively it evolved over time. And what we have now is hydraulic control. It's still there because we need to manage stormwater in cities. We have other uses of the water. We need to treat it. It's usually a water resource for cooling the temperature in summer, to irrigate, to refill the aquifer. Usually there is a trend to reopen the water courses, to introduce nature in cities, to increase urban ecology, to contribute to the climatic and temperature control in fight against heat island effects. You have to, or you combine your stormwater management with architecture. If you go in the direction of urban farms, urban agriculture, you can also link your stormwater management with food production, with energy savings, citizen well-being, public health, and you combine that with society and cultural needs. So we are in a more and more complex approach, trying to combine different objectives into the urban project, where stormwater is sometimes a key point, sometimes not, but try to associate different requirements and goals. And we also, on the same line, move from oneness, only one solution, pipe systems, to a much more diverse approach. But this is not the end of the story. We need to continue to imagine and embed. And for example, we wrote with many colleagues the IWL principles for water-wise cities. And if you read this short document, it's another vision that's where you can embed your stormwater and wastewater systems at the city scale and also at the catchment scale, because the cities are not islands in the middle of nowhere on the territory, but they are strongly interconnected with the upstream catchment, the downstream catchment, and how to interact also with citizens. And this is how to reconsider the central place of water in cities. But it's not easy. This is an example of Greater Lyon. Imagine the old system. You have a road a pipe system under the road. And the pipe is operated by the sewer system, the sewer department. The road is operated by the road department. On the side, you have green, you have trees, you have parks, and this is operated by the Parks and Garden department. And in the past, each department had its own responsibility. But nowadays it's complex, it's much more complex, because the road may be porous, or you have no more a pipe, but you have a swale along the road. So what is the limit between the parks and the gardens and the road? Who is in charge of the maintenance of the cleaning of the swale? Is it the people in charge of the road? Is it the people in charge of the stormwater, formerly working with sewer systems? Is it under the responsibility of the Parks and Gardens department? And this is a thesis, PhD thesis by Nina Kosei, and she investigated these difficulties. And you can observe here, with different colors, the different departments involved and the responsibilities which were clearly defined in the past are becoming much more sometimes overlapping or fuzzy, and the city needs to completely redefine the boundaries and the responsibilities of the different technical services when you create new infrastructures which are much more integrated. And it's a long process. And this is another way when you take a more urban area in the city center between the solid waste, the road, the water departments. So everything is now becoming more complicated to manage. And you have to deal with that, and you have to plan it in advance, because once your infrastructures have been changed, they need to be operated for decades, and you should anticipate how you will manage your new infrastructures. And this is what they did in some cases in Lyon, with these porous pavements which are developed. They develop lots of swales and infiltration systems in different places, more or less natural. They develop this type of rain gardens. And one of the most interesting detail is the sidewalk. In the past, they were higher than the road. And now you should invent something which is lower so that the stormwater and the runoff can go into this area. And this is a question of a few centimeters difference in the levels of the streets and the sidewalks, and how the water can run off on the streets, on the surfaces, and reach the places you want them to be infiltrated and used for your trees and vegetation. They reopen water courses which were hidden in the past, and they create more artificial ponds, like the first examples I have shown in port design. The title of your colloquio is Nature-Based Solution. So to some point, it's involving biomimicry. The idea was already presented or developed by Rachel Carson in her book Silent Spring in '62. That we can be inspired and mimic nature. And you have a more detailed approach in this book by Janine Benius, entitled Biomimicry. And she gave 9 principles, the 9 principles of biomimicry. And if you use them, you can have a different vision of how to manage your stormwater in cities. And usually NBS, surprisingly for me, is nature-based solution, but the words biomimicry or biomimetism is really very rarely used. So maybe we can go one step further and go in that direction. And to conclude my presentation, I'd like to show you a few last slides. This one is drawing by Luc Schwitten. It's a Belgian architect and a graphic designer, and he is working since many years on the vegetal city. And this is how Lyon city center, you have this tower near the big railway station here. And it was like that in, okay, let's say 10 years ago. And the city of Lyon invited him to make the design of the future. What is your idea for Lyon in 2100? And this is the vision of Luc Schwitten. So it's a dream that you see much more nature, vegetation, interconnection, and it's a step in a much more long-lasting project. Of course, what we have today in Lyon is no longer this. It has been significantly improved over the last 11 years. This area is under a complete retrofit in these years, but we will still remain far from that vision. And I will conclude my presentation with this last slide. It's a design of Vincent Calbon, another Belgian architect, sorry. It's an extension of Geneva near Switzerland on the Rhone River. And what I like is the sentence from another author, that the urbanists of the future will be indistinguishable from gardens. Muchas gracias por su atención.
Muchas gracias, profesor. Ahora vamos a pasar a la sesión de preguntas. Sí, la verdad fue una presentación muy interesante y creo que tocó un poco los temas que tenemos también en México. Por ejemplo, estaba presentando un ejemplo de gran obra de drenaje en Portland, Oregon, y yo pensé, no, pues es lo mismo en la Ciudad de México, ¿no? Que se acaba hace un poco más de un año se inauguró un megatúnel de drenaje de más de 60 kilómetros y de a veces más de 100 metros de profundidad. Entonces, como es un tema que es muy presente en México. Les recuerdo a todos los asistentes que pueden hacer sus preguntas en el chat, que sea en Zoom o en Facebook o en las otras redes sociales. Voy a iniciar con una pregunta de Susana Ezeta del PAUNAM. Dice: ¿qué tan conveniente es infiltrar al suelo el agua jabonosa de las regaderas y lavabos, ¿no? O lo que se llama como aguas grises? ¿Piensa, profesor, que es algo que se puede hacer o que tiene sentido hacerlo?
In Lyon, the most recent stormwater regulation requires that you infiltrate the first 15 millimeters, 15 millimeter of each rain event. And as I said, there are some districts in this municipality where it's forbidden to connect your roof, your asphalted garage alley or something to the stormwater pipe. Of course, you should have investigations of the soil and of the potential risk or possibilities for infiltration. But in many locations, you can infiltrate, yes, a lot. And you can infiltrate slowly. If your local geology is not with a very high hydraulic conductivity, you don't need to infiltrate in a few hours. You can last, you can have an infiltration over 10 hours, 12 hours. So in many locations, it's, yes, you can infiltrate a lot. But then you have to also you should do it carefully. Analyze how is your underground. Do you have an aquifer? Is it deep? Should you protect any water resource? Because when you infiltrate stormwater, it's not drinking water. Huh? It's not, you have some contaminants, you have some pollutants. But if you infiltrate water coming from your roofs, from individual houses, usually the contamination is very, very limited. So there is no big risk for infiltrating this water.
Muchas gracias.
And another point is there is a trend to develop more and more green roofs. to promote evapotranspiration. So if you try to combine on a short time scale, which is a few hours, you can infiltrate. And on the longer time scale, hours, days, weeks, you can evapotranspirate. So the idea is to create some green roofs with some storage capacity. So the water on the roof is stored on the roof and is left available for evapotranspiration by the vegetation. And we did some scenarios and simulations, and you can evapotranspirate sometimes 50% of your rainfall. So infiltration is only one part of the solution, but I would recommend that you don't base your solution on a single mode.
Muchas gracias, profesor. Tenemos una otra pregunta de L. Gabriel, que dice: gracias por la presentación, doctor Bertrand-Kashevsky. En el sistema combinado que menciona, ¿cada cuándo es recomendable realizar el mantenimiento y qué se hace con los residuos de sedimento que se retiran del sistema de drenaje? Y para el sistema de el tema de los microplásticos, ¿aplica alguna tecnología en específico para su tratamiento?
Okay, the first part of the question is combined systems. Yes, combined systems, in some locations, you may have some sedimentations and deposits, and you have to manage them. And it may be very expensive. So what we observe since 40 years or 30 years is try to improve the grid chambers and the sediment chambers which are built in sewer systems to have something which is more efficient, with specifically designed sediment traps. So it's an entirely different topic, but yes, and it's also very important because it's very difficult to close the mass balances, but it also appeared in some catchments that during storm events, the resuspension of your sediments in combined sewers may represent 20, 30, sometimes 50% of the suspended loads transported by, for example, by your CSOs, your combined sewer overflow. So the resuspension of these sediments is critical, and it's also the support of many pollutants. And on the long term, combined systems will be more and more complicated to manage, because on one side we have declining water consumption. For example, in France, we went down from 150, 60 liters per inhabitants. Now we are close to 120, 110 liters. So you have less water transported in your systems. If you disconnect more and more stormwater, you are going back a little bit to something like what was observed in the 19th century, that people expected the rains to cleanse the combined sewer system. So we have to pay attention also to this aspect. But globally, the most recent national guidelines in France do not recommend to further develop combined system. The guidelines is disconnect, infiltrate, treat, and manage separately your stormwater. And the stormwater and combined sewer systems is no longer the most or the best idea. But in many historical city centers, we have them, so we have to manage them. Regarding microplastics, there are some colleagues in my labs working on that at the research level. At the moment, we are still far from treatment. We are just trying to quantify the problem, to investigate what kind of plastics do we have, under which format, which shape, and what are the attached pollutants, how they behave, and specific treatment of microplastics as far as I know, but it is not really my field. Okay, I don't know, to be very honest, so I don't want to say stupid things, but at the moment, what I know is that we don't have specific objectives to treat microplastics in wastewater treatment plants.
Muchas gracias por su respuesta, profesor. Tenemos otra pregunta de Olga Sorchit Cisneros, que que pregunta, doctor Jean-Luc, desde su perspectiva, ¿se requieren incentivos fiscales o crediticios a instituciones o gobiernos municipales que ejecuten estos proyectos sustentables con uso de tecnologías alternas? Entonces pregunta sobre el tema de incentivos fiscales o crediticios.
It's a very complex question. It depends on your national regulations. For example, in France, the water bill includes your access and your consumption of drinking water and your contribution to the wastewater collection and treatment. And when you have to deal with stormwater, it's not covered by your water bill. It's covered by the municipal taxes you have to pay where you live. But it's a political decision to organize the system like that. In other countries, you may have different organizations. So it's difficult. I don't know where you live, if you are in Mexico or in other places. The only thing which is true everywhere is you need resources to build your infrastructure. And in the past, when it was pipes and collecting systems, it was usually owned, paid, and built by public authorities like municipalities or any other kind of similar organizations. When you start to integrate your stormwater management in architecture, in landscaping, it's much more complicated. For example, if I build a house with a green roof to facilitate the stormwater management, my green roof is a kind of extra cost compared to a traditional roof. But I will not spend some money to build a pipe system because I can manage my stormwater only with my roof and some additional infiltration. And who is paying for that? And it's when you transfer the water differently, we also transfer the money and the resources differently. And my perception is, to some point, the technical transition is going sometimes and in many places faster than the transition of the financing system. But it's another part of the integrated approach, how you will fund your system for investment, building, and for operation. Because again, if I use the example of my green roof, I need twice a year a visit of my green roof to check that everything works well. And so who is paying? Is it a public service because you contribute to the stormwater management in your city, or is it my private responsibility and my private cost because it's my roof? And this is also why, for example, in some places, these NBS solutions or stormwater management solutions are managed at the public level, but as close as possible to the houses. So you don't have pipes, but instead of having the infrastructures owned by private owners, it's owned and managed by the public system. So it's a way to combine things, but again, it's a case-by-case study and analysis.
Muchas gracias, profesor. Tenemos otra pregunta que es un poco relacionadas con esta última, que es de Eugenia García Velarde, que pregunta: ¿quién coordina este proyecto y desde qué ministerio? Me imagino que es aquí en el tema de Lyon, ¿no? En el cual habló bastante usted. En este caso, ¿cómo se organiza esta gestión y quién coordina estos proyectos? ¿Es el municipio? ¿Es el Grand Lyon? ¿Cuál entidad maneja cuál tipo de proyecto?
So, Greater Lyon is gathering something like a little bit less than 60 municipalities. And the central municipality is Lyon, which is the largest one. And in such a French administrative organization, when you have this urban community, that's the legal name we use, you decide for each urban community which departments are in the hands of the urban community and which ones remains in the hands of each individual cities, municipalities. In the case of Lyon, like in many French urban communities, the water is managed at the Greater Lyon level. So the big decisions and the master plans and the regulations that people have to apply and follow is decided by the Greater Lyon for its entire territory. Of course, these rules decided by Lyon should be in coherence with national law and guidelines. But each municipality has the autonomy and the power to decide locally their rules to manage stormwater.
Muchas gracias, profesor, por su respuesta y quiero agregar que sobre este tema, para los participantes aquí, invitarles que justamente el 22 de junio, como parte de este coloquio, vamos a tener una mesa redonda sobre este tema de cómo manejar o cómo integrar estas soluciones basadas en la naturaleza desde una perspectiva un poco de administración y de gobernanza, ¿no? Entonces, será de mucho interés para la gente que quieran profundizar sobre este tema de la gobernanza del agua. Y por cierto, quiero también saludar a que es un poco relacionado con este tema, justamente que tenemos aquí un ponente como participantes, que está aquí como oyente, un ponente que tuvimos el placer de tener con el seminario en línea que hicimos el año pasado para las soluciones basadas en la naturaleza en Latinoamérica, que es Eduardo Hinojosa Robles, que platicó justamente de la comunidad urbana de Hermosillo en Sonora, en México, donde cómo podían integrar estas soluciones basadas en la naturaleza para la gestión hídrica. Un saludo, Eduardo. Voy a seguir con las preguntas. Tenemos bastante preguntas. Se nos está acabando el tiempo, pero voy a tratar de pasar algunas más. Una pregunta de Daniela Noriega que dice en temas normativos, ¿cómo se regula, promueven o establecen criterios para el uso de soluciones basadas en la naturaleza? ¿Quiénes son los sujetos obligados al cumplimiento de esta normatividad?
It's a complex question. In France, we have some guidelines, or some national guidelines are given by the Ministry of Environment and recommends to develop local stormwater management to promote infiltration, evapotranspiration, and nature-based solutions. So it's the trend. But these national guidelines or technical guidelines do not include very detailed specific standards. So this is the direction in which you have to go. And then for very specific design, it's in the hands of the municipalities, as I mentioned before. So you have different rules. For example, the rules to manage stormwater in Lyon are not exactly the same as the rules in Paris, and as in Marseille and in each city in France. So there are some big orientations, wide orientations given by the national French government in the laws. And then locally, you define some specific standards, values, objectives you want to reach.
Muchas gracias. Sigo con tenemos muchísimas preguntas. Sí. Sigo con una de Joaquín Flores, que pregunta cómo lograron concientizar a la población para que aceptaran estos tipos de proyectos y las nuevas áreas verdes y no la conviertan en basurero, que es un tema desafortunadamente común aquí en México y quizá en otros lugares de América Latina.
the city of Lyon tries to do more effort in the future in that direction. There are, if you want to go have better experiences in this field, maybe France is not the best example. You have a more interesting example. For example, the case I mentioned in Montreal, Canada. They had a project, once they had the first design and ideas, they came and visited the inhabitants, discussed with them. By tradition, the French approach is more, a top-down approach. And it's one of the points that could be improved in the future to involve more the inhabitants, their reactions, their wishes in the project. And when you ask how can the people accept these solutions, we are working since many years with sociologists, and some of them don't like these words. It's social acceptance, but they don't like the work or the wording social acceptance, because it involves that people have to accept something they have not been involved in before. So the idea would be to be more proactive and work and involve the people in the design of the project. And for example, the city of Lyon has a partnership with the city of Montreal and Quebec, because in these Canadian cities, involvement and participations of citizens and inhabitants is more developed and more usual than what we have in France. So I would suggest that you can look at these examples. We are more advanced on this aspect.
Muchas gracias. Voy a hacer las últimas preguntas. Voy a combinar una pregunta de Julio Soriano y una de Ildefonso López. Julio, que pregunta, ¿cuál es la, pregunta en inglés, what is the feasibility of implementing stormwater utilities in medium-sized Latin American cities for the construction and maintenance and nature-based solution to properly manage the environmental impact of stormwater pollution and to provide adequate flood protection? So, what is the feasibility? What do you think? How feasible it is to implement this type of
sound anymore.
Perdón, es que estaba en inglés, pero lo voy a hacer en español. ¿Cuál es la feasibilidad de implementar este tipo de proyectos en América Latina? Si tienen algunos ejemplos conocidos para este tipo de proyectos en América Latina, especialmente para las ciudades de tamaño medio. Y la pregunta de Ildefonso es ¿cómo asegurarse del mantenimiento de estas infraestructuras? En México se han hecho proyectos interesantes, pero el problema es el mantenimiento. Y lo que se avanza se pierde en el tiempo porque no se le da el mantenimiento. Hay dinero para inversión, pero no para mantenimiento. Entonces, no sé si hay alguna sugestión de cómo se podría mejorar este tema.
Okay, thank you. Latin America. I don't want to claim that I know everything in Latin America and to give you advices, but in the past, I had opportunities to have collaborations with colleagues in Brazil, also in Colombia, in Bogota, and I have seen that there are some very interesting developments in the same direction. So I don't see why it would not be possible in Latin America. And if you remember my presentation, it should be based also on your local habits, your local vision of water. So you cannot directly transpose what you have seen in my presentation to any place in South America, but having the main guidelines in mind and trying to go in one given direction, then you can adapt these principles and to develop something which is locally appropriate and which is able to gather people around your project locally. And I remember that when Laurent Courty prepared this event last year, some other colleagues in Bogota, for example, I have some colleagues in Bogota in La Javeriana University. Andres Torres, he has some experience and practice on that in this country, and a few other colleagues, so I can give you some names if you want, but maybe you know them better than me. The other question was, sorry, I lost it in the way.
About maintenance.
Maintenance. Yeah, maintenance is of course is a very important aspect. It's like any facility you build, you need maintenance. The experience has shown also that if you have a very good design, you will minimize or reduce the maintenance. It will never be zero, but for example, in Lyon, they started to build some swales infiltration on the side of the road. And people started to use them to park their cars. And then it was a problem because then you have solid waste, then you have a compaction of the soil and things like that. So the idea is to not to create a fence, but to have some stones of blocks of wood from place to place to avoid cars can be parked. And you have lots of details in the design that you can learn by experience or learn by going into detail of conception with some experienced people to minimize the risks, to minimize the blockages and the needs of maintenance. But in any case, maintenance is necessary, should be included in the design of the project. This is why I mentioned this, how you make the different departments of cities to work together on that. And also there is a cost that you have to plan, of course. And I have some colleagues in my lab who are working on this maintenance and asset management of NBS for stormwater management. And for example, we are working, how can we monitor them? But monitoring is usually expensive. So we are working with low-cost sensors. So for monitoring water level, monitoring where the water is flowing, it's something for a cost of a few tens of euros instead of thousands of euros when you compare with traditional sensors. So yes, but maintenance is important and should be planned at the early beginning of the project.
Muchas gracias, profesor. Ya acabamos la sesión de pregunta y vamos a terminar esta sesión transmitida, y por las personas que quieren seguir la conversación de manera más relajada con el profesor Jean-Luc Bertrand-Kajewski, vamos a tener en unos 5 minutos, después de un pequeño receso, una sesión de coffee chat en cual se podrá hacer una discusión un poco más relajada con el profesor Jean-Luc Bertrand-Kajewski. Muchas gracias a todos. Los que quieren seguir en este coffee chat pueden quedarse conectados y tal vez algunas de las preguntas que no pudimos contestar ahorita, porque eran muchas, se podrán preguntar en este espacio. Entonces, esta sesión de coffee chat será moderada por la doctora Carolina Escobar Neira, subcoordinadora del Instituto Mexicano de Tecnología del Agua. Voy a regresar la palabra a Marco Sánchez para que él haga algunos anuncios para ir a esta sesión de coffee chat. Muchas gracias, usted se queda con nosotros y regresamos en unos minutos para este coffee chat. Adelante, Marco.
Muchísimas gracias, Laurent. Muchísimas gracias, doctor Jean-Luc Bertrand-Kajewski, por esta magnífica presentación, una inmejorable forma de iniciar los trabajos de este Coloquio Internacional Soluciones basadas en la naturaleza para la gestión hídrica. Y yo quiero invitarles a todas y a todos en este momento a, si así están de acuerdo, que de manera conmemorativa podríamos, quienes así lo quieran, compartir, abrir sus pantallas, encender sus cámaras para que podamos tomar una foto de grupo donde podamos preservar esta fecha muy significativa que es el inicio de este coloquio, 1 de junio de 2021, en compañía del doctor Jean-Luc Bertrand, con Laurent Corti y con todos y todos quienes han estado participando muy activamente. Y no se preocupe, vamos a hacer ahorita esta toma compartir, esta toma fotográfica. Vamos a tomar un breve receso para que podamos estirar un poquito las piernas, servirnos café y quienes así lo deseen continuar conectados, no se desconecten en este mismo enlace para poder continuar charlando con nuestro invitado de esta mañana, invitado de lujo para iniciar el trabajo de este seminario, y estará moderado por la doctora Carolina Escobar Neira, subcoordinadora de participación social del Instituto Mexicano de Tecnología del Agua. Si están de acuerdo, entonces en lo que encendemos todas nuestras cámaras, yo voy contando del 1 al 3 y cuando contemos, el equipo de comunicación hará estas tomas de las imágenes para que podamos preservarlo, y les invito a que no se desconecten para continuar con esta charla de café. Vayan por su café también, una buena recomendación, café, agua, lo que prefieran beber para seguir conversando relajados con nuestro invitado de esta mañana. Y a lo largo del receso que estaremos teniendo, les invitamos a que tengan en pantalla, que vean en pantalla las próximas sesiones que tenemos de este interesantísimo coloquio todos los martes y jueves del mes de junio para que lo puedan organizar de la mejor forma en sus agendas personales. Entonces hacemos esta toma fotográfica, esta imagen del recuerdo, vamos a este receso y en 5 minutos más nos volvemos a conectar para continuar con la charla. Entonces, a la cuenta de 3, nos regalamos una gran sonrisa como parte de esta comunidad de conocimiento, de vinculación en torno a las soluciones basadas en la naturaleza, este 1 de junio de 2021. A la cuenta de 3, 1, 2 y 3. Hacemos tal vez una segunda toma sin que nos demos cuenta. 1, 2 y 3, regalándonos una gran sonrisa. Y muchísimas gracias a todas y a todos. Doctor Adrián Pedrozo Acuña nos acompaña también desde la Dirección General del Instituto Mexicano de Tecnología del Agua. Les invitamos, no se desconecten, permanezcan quienes quieran continuar con la charla. Y pues estaremos aquí compartiendo con ustedes las siguientes fechas de este coloquio. Y también están, por supuesto, disponibles para todas y todos en el programa que está publicado en la página web, y estaremos publicando las notas y lo más relevante que va ocurriendo y que vamos compartiendo con ustedes en este seminario, en este coloquio. Muchísimas gracias y nos vemos en 5 minutitos más. Hasta pronto. No nos despedimos.